Everyone, welcome to the last video of the semester. Woohoo! So this handout is our last section. It's in the note packets in Blackboard, and what I want you to do to start off the video is to review a little bit. So give it a pause and try these first two questions that were on the material we covered on Wednesday with the square root property. Okay, so give it a pause, try those, and then come back and see how you did. All right, so the square root property says that you can isolate the squared term, and that's going to have an x in it, and then no other terms will have an x in it. So we can isolate this term that has the squared by dividing both sides by 3. Okay, and then it's all about undoing operations. So to undo a square, we can take the square root of both sides. Just don't forget that we have to sneak in the plus and minus in front of that square root symbol, and that the square and the square root cancel each other out. So the x minus 5 is just going to fall out of that square root symbol. So we'll have x minus 5 equals plus or minus 2. And then to undo subtraction, we'll add a 5 to both sides. So x will equal plus or minus 2 plus 5. So we'll have positive 2 plus 5, which equals 7, and then negative 2 plus 5, which will equal 3. So there's our two answers. And the nice thing about these is that you can check them. So the original problem is 3 parentheses x minus 5. So I'm going to put 7 in for x. Did we get 12? Yep. And then we'll go ahead and put 3 in. 3 minus 5 squared. So you can check them, right? You can check those out pretty easily. All right, let's see how you did on this one. So in this case, I can isolate the x squared by adding 2 to both sides. So we'll get x squared equals 81. To undo the square, we take the square root of both sides. And then don't forget about the plus and minus that has to come in front of that square root symbol. So x is going to equal plus or minus 9. So this is great because these problems, it was easy to isolate the squared term. Now I want you to check out this one right here. If I said solve by using the square root property, if you isolated the x squared, you're still going to have an x on the other side of the equation. So the square root property only works is if you can isolate the x term that's going to have the square in it, and no other terms are going to have an x in it. So that's the problem. So you cannot use the square root property here because you can't isolate the squared term and have that be the only one with the x in it. Now we can solve this with factoring. All right, so this one is factorable. The a value is 1, so we can jump right into our binomials. We don't need AC split C. Our c value is 8, and then when we break this apart into its factors, we get 1 and 8, and 2 and 4. We look at that middle term, which is negative 6, and say, okay, they both have to add up to a negative, so we'll make them both negative. And negative 2 plus negative 4 equals negative 6. So then we set each factor equal to 0. If we add 2 to undo subtraction, we'll get x equals 2. And if we add 4 to get rid of the subtraction, we'll get x equals 4. Pop that up there so you can see it. There we go. All right? Now sometimes, as we know, quadratics aren't factorable, but they still have x values that will satisfy the equation. So if that's the case, there's another technique that's called the quadratic formula. And that's what we're going to use in this next problem, right? Now we already know the answer to this, but we're going to resolve it using the quadratic formula, okay? All right, so let me write down the problem again. Okay, let me pop up the problem, and then we're going to solve it using the quadratic formula. So the problem is x squared minus 6x plus 8 equals 0. Okay, just like factoring, you've got to get one side equal to 0, which is already done in this case. And then you have to identify what the a, the b, and the c are. So a is the number in front of x squared, b is the term in front of x, and c is your constant. And then we are just going to plug and chug through this formula. You do not have to memorize this, right? I will give it to you on a test and on the final, but you do need to be able to apply the variables and put it through your calculator. So let's see, b is negative 6, so it's negative b plus or minus the square root of b squared minus 4 times a times c, the whole thing, make sure you extend that whole line all over 2a. Now when I do this, I usually figure out what's underneath the square root symbol. That's what I just do first. It's just the habit. I don't do it in one shot. So let's see. The negative of a negative of 6 is positive 6. And I'm just going to see what's underneath that root symbol. You ready? So we have negative 6 squared minus 4 times a times c. I type it in exactly how I've written it. So we have 4 all over 2 times 1 is 2. Okay, we can do this. 6 plus or minus square root of 4 is 2 all over 2. So we're going to have 6 plus 2 over 2 and 6 minus 2 over 2 as my answers. So 6 plus 2 is 8. 8 divided by 2 is 4. 6 minus 2 is 4. 4 divided by 2 is 2. So there are our two answers, and that's what we got before. 2 and 4. Okay? So all we're going to do is practice using the quadratic formula, and then we're going to look at some wordy type problems that will be on the test and on the final. All right. So these questions, if you tried to factor them, they're not factorable. Okay, so it's okay if we get some weird looking answers that we're going to have to round. First thing first, though, is you've got to get one side equal to 0. So I'm going to subtract 2 from both sides and call this 5x squared minus x minus 2 equals 0. And now we can identify what the a, b, and c are. So a is equal to 5, b is equal to negative 1, and c is equal to negative 2. All right, here we go. So here's what the quadratic formula is. You ready? So x equals negative b, negative of whatever b is, plus or minus the square root of b squared minus 4 times a times c, the whole thing over 2 times a. Okay? All right, so let's pull out our calculator and see what this looks like. So we're going to have the negative of a negative 1 is 1. Plus or minus the square root. Let's see what we get for this. You ready? And I'm typing it in exactly how I see it. If there's a parenthesis, I put my parenthesis. Minus 4 times a times c. Negative 2. So we have the square root of 41 all over 10. Now that's an exact answer. There's no rounding required, which is fine. So now I'm going to put the two answers into my calculator. And we've got 1 minus square root of 41 all over 10. Okay, so in one fraction in the upstairs, it's better right there, I've got 1 plus square root of 41, and that's all over 10. So change it so we can get a decimal. 0.74. Okay, if we round it to 2, and then we'll get 1 minus square root of 41. You can do it this way, divided by 10, and then change. Negative 0.54. How we do, okay? Does that make some sense, I hope? All right, let's try another one. You ready? So the first thing we're going to do is we're going to get one side equal to 0. So I'm just going to subtract 10x and add 3 to both sides. So these all cancel, and we'll have 2x squared minus 10x plus 3, and this will all equal 0. So we have a is 2, b is negative 10, and c is 3. Right? We've got 2, negative 10, and 3. All right, so let's go slow. So x equals, boy, I don't know, I randomly picked these out of my math lab, and it seems like all the b's are negative. So we have negative of a negative 10 plus or minus the square root of b squared minus 4 times a times c. The whole thing is over 2 times a. Right? So negative of a negative 10 is 10. Plus or minus. So let's practice what's underneath this. You ready? Trying to find a spot where you can see it. So we'll have negative 10 squared minus 4 times a times c. So square root of 76 is underneath our root symbol. Or 76 is underneath the root symbol, all over 4. So that's an exact answer. That's an answer that we haven't had to round. So we'll do 10 plus root 76 over 4, and then 10 minus root 76 all over 4. And we'll round it to 2 decimals. Okay, ready? So I'm just going to use my fraction key. So I'll have 10 plus root 76 on the top, all over 4. And then I just remember the change key. So I got 4.67, 4.68 when I rounded it. 4.68. And we'll do it again. So I'll have 10 minus square root of 76, all divided by 4. And then don't forget just to hit the change. So 0.32. How's that? Is that okay? So why don't you all give it the next one. Oh wait, I think the next one has wonky fractions in it. Yeah. Let's get rid of the fractions. You don't have to get rid of the fractions, but they're kind of ugly looking. So I tend to get rid of them. So I'm going to multiply every single term by 4. Right? You find the first common multiple they have in common. Okay? So you get a 4. Yeah, right here. The first term gets a 4. The next term gets a 4. And the last term gets a 4. So if you put 4 times 1/2 into your calculator, that'll give you 2. If you put 4 times 5/4 in your calculator, you'll get just a plain old 5. That's what I mean. And so the last one, if you put a 4 times 3/2 in your calculator, you get 6. See, the fraction's gone. Woo! All right, much easier to look at, right? So let's subtract 6 because we have to get this equal to 0 before we can make our A, B, and C assignments. And once again, the B values equal to 0, negative. I don't know why I did that. Randomly picked those out of my math lab. All right, so A equals 2, B equals -5, and C equals -6. So why don't you pause the video and try popping those into your quadratic formula and see if we get the same thing. All right, let's see how you did. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. Oop, which is 2 times 2. All right, so we'll have 5 plus or minus. Let's figure out what's underneath that square root symbol. You ready? The moaning you hear is my dog in the background. All right, sorry about that. So -5 squared minus 4, oops, minus, there we go, 4 times 2 times -6. So let me check it. It's distracted with Lucy's complaining. 4AC. Okay. So 73. And this is all over 2 times 2, which is 4. So we've got 2 answers. 5 plus root 73 all over 4. And 5 minus root 73 all over 4. Okay. So we've got 5 plus root 73 divided by 4, and then we'll hit change. So 3.39 for this one. Let's try the next one. You ready? So 5 minus root 73, I'm going to hit enter, divide by 4, and then hit change. So -0.89. All right. So here are the twists that they're going to throw at you. They're going to give you a quadratic and say find the x-intercepts using the quadratic formula. So not a big deal, because we know if you're an x-intercept, the output is equal to 0, or the y value equals 0. So this is already equal to 0, so we're good to go. Just go for it. You ready? A equals -3. B equals 5. And C equals -4. All right. So x is going to equal -b. Finally, we got a b value. It's not negative. Plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's see what's underneath that square root. Ready? So we have 5 squared minus 4 times A times C. Oh, okay, this is good. I'm glad this happened. So we've got a negative underneath our root symbol. Can we take the square root of a negative number? I thought these indeed had x-intercepts, but they must not. You cannot take the square root of a negative number. So I'm going to show you, I'm going to put this into my graphing calculator and show you what the graph of this looks like. Okay, you ready? So I assumed that it had x-intercepts, but it doesn't. So you cannot take the square root of a negative number. Interesting. So if this happens on my MATLAB, which it might because I pulled these off of my MATLAB, there are no x-intercepts. None exist. Okay, so let me show you what the graph of this looks like. So you'll be doing this kind of stuff in 1215 if you next semester. Ready? So I'm going to put in negative 3x squared. This is what's called a graphing calculator. They're really cool. And you can look at the graphs of these without having to go through using graph paper. Aha, so this is what the graph of this looks like. Now look, it's a parabola. It opens down like a frown because the A is negative. But look, the vertex is not above the x-axis. The vertex is below the x-axis, so there are no x-intercepts. So either I copied it wrong off of my MATLAB, or there are some that don't have any x-intercepts. Okay, that's okay. Very interesting. That was a little surprised by that. All right, so if you get a negative under the square root symbol, then they don't exist. All right, let's try the next one. Hold on, I'm going to pop this in. All right, before we even do it, I'm going to graph it to see if it's got some x-intercepts. I don't know. I didn't check it before. Okay, this has got some x-intercepts. You can see it. It opens up like a cup because the A is positive and it's crossing through twice. So we're good. We've got some x-intercepts. Okay, here we go. So x-intercepts are when y equals 0 or the output equals 0. All right. So we have A equals 3, B equals 4, and C equals negative 1. All right, so let's pop this in. So x is equal to negative of a negative 4 plus or minus the square root of 4 squared minus 4 times A times C all over 2 times A. All right, negative of a negative 4 is 4. Wait, B is positive 4. So it's negative of a positive 4. Hold on, get rid of that. I screwed up. See, unedited. All right, B is 4. So it's negative B. So this is going to be negative 4 plus or minus square root 16. Oh, well, I should put this in my calculator. Here, let's put it in my calculator. Ready? So we've got 4 squared. There's Lucy complaining again. Minus 4 times 3 times negative 1. So did you guys get 28 underneath the square root symbol? Plain old 28 all over 6. So we'll get negative 4 plus root 28 all over 6 and negative 4 minus root 28 all over 6. right, let's see what these look like. So negative 4 plus root 28, hit enter, divided by 6, change. So it looks like 0.22 is one of the roots. So if I had to graph it, that'd be really close to 0. I'll use the fraction key this time. Okay, so put the numerator upstairs. Here's my denominator and hit change. So negative 1.55. And you know what? If we look at the graph of this, I know we're not using graphing calculators yet, but you can kind of see that, right? So the one on the right must be the 0.22, and this is definitely between negative 1 and negative 2. Like almost looks like it cuts right through the middle. Here, I'll zoom in on it a little bit. Right? Do you see that? So that makes sense. So our answers make sense if this is the graph. This is really close to 0, and that's stuck between negative 1 and negative 2, almost halfway. All right? Isn't this cool? We found it algebraically, and I just took a peek at my calculator to check it graphically. All right, and the last little bits, and these tend to be some challenges, okay? The wordy problems that'll be on the test and on the final. It's quadratics. If you go very slowly with them, you should be perfectly lovely, all right? So let's look at this one. So the baseball is hit by a batter. A baseball is hit by a batter. The height in feet of the ball after t seconds is given by this formula. So it's kind of like the fireworks one, right? So we have our baseball player. Here, I'll put a little hat on him or her. Okay. So here's the bat, right? Make it a little bit longer. Looks like a sword, but whatever. Okay, so doesn't it make sense when they hit the ball, right? It's in the shape, its path is a parabola, right? They hit it, it comes up, and then it'll come back down, right? Can you see that beautiful drawing? Okay. Now, the cool thing about this, let's see if I asked you that question. Yeah, the y-intercept. We'll get to the y-intercept. All right. So, but anyway, you got the idea why this is a parabola. The path of the ball is a parabola. It's upside down like a frown. Can you see my path? Yep. And which is correct because look, the a value is negative. So that makes sense that it's going to be down like a frown because a is negative. So the path of the ball makes sense. So it says, what is the height of the ball after 2 seconds? So t is 2. So h of 2 will be negative 16 times 2 squared plus 125 times 2 plus 4. So we're just going to pop 2 in there, right? Ready? So we've got negative 16 times 2 squared plus 125 times 2 plus 4. So it looks like the height of the ball is 190 feet in the air. All right, now this one's a tricky one. When is the ball a height of 200 feet? Okay, well, this is where the quadratic formula is going to come in handy. All right, so we know the height, but we don't know the time. So in order to use the quadratic formula, we have to get one side equal to 0. So we'll subtract 200 from both sides. And assign our A, B's, and C's, right? So A is equal to negative 16. B is equal to 125. And C is equal to negative 196. And we're just going to plow it through the quadratic formula. Quadratic formula is used to solve quadratics when one side equals 0. So x is going to equal, oh, it should be t, actually. We're not using x's right now, we're using t. So t equals negative b plus or minus the square root of b squared minus 4 times a times c. Squeeze it in there, 196. Ooh. All over 2 times a. All right, so it's going to be negative 125 plus or minus. Let's see what's underneath the square root symbol. You ready? We have 125 squared minus 4 times a times c. Did you guys get 38 square root symbol? I'm going to do it again just to make sure. Yep. And this is all over negative 32. Okay? So I'm running out of room. That's okay. So I'm going to have two answers. I'm going to have negative 125 plus root 3081 all over negative 32. And I'll have negative 125 minus root 3081 all over negative 32. So let's see what these two answers are. You ready? So fraction 125, whoop, nope, negative 125. Holy schmacks, let's try it again. There we go. Negative 125 plus square root of 3081, and this is all over negative 32. So I got 2.17 seconds. And then let's do it again. Negative 125 minus square root of 3081 all over negative 32. And then 5.64 seconds. All right, why two answers? So there's one time, and there's the other time. Well, this should make sense, right? That there are two answers. So it's going to be at 200 feet at two different times, right? Going up when it's riding up the path, and then when it's coming back down, when it's taking its descent. So this is like at 2.17 seconds, and this would be at 5.64 seconds. We could even find when it turns directions. If they ask you to find the vertex, maybe we'll throw that out there too. Okay, but here, I'm running out of room. Well, maybe we can get it all in here. So when does the ball hit the ground? I'll squish it in here. So if the ball hits the ground, that means its height is 0, right? Height is 0 if it's on the ground. All right, so negative 16t squared plus 125t plus 4. All right, so A equals negative 16, B equals 125, and C equals 4. All right, let's see if we can squeeze it in here. So t equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Right, so let's figure out what's underneath my root symbol. Okay, so I'm going to have 125 squared minus 4 times A times C. So 15,881. Oh my goodness, now my dog's growling. I'm so sorry. Divided by, so sorry. Okay, she's usually sleeping when I do this because it's like 9 o'clock at night, not like 1 in the morning when I'm usually doing it. Okay, so here we go. So sorry. What's wrong, Lucy? Her name's Lucy, and I can't turn the video, so you can't, like, it's this old camera, so you can't see what she's looking at. I don't know what she's looking at. Probably a deer in the yard. Okay, so we've got negative 125 plus root 15,881 divided by negative 32, and negative 125 minus root 15,881 all over negative 32. All right, definitely running out of room, so I'm going to just flip a piece of scrap over. You ready? All right, so what are the 2 times? You know, it's going to be longer than like the 5.464 seconds, but I don't know how long. So negative 125 plus root 15,881, and this is divided by negative 32. All right, now that's a negative time. Oh, shoot, sorry about that. I'll do it again so you can see it. So negative 125 plus root 15,881. There it comes. Sorry. I don't know what she's barking at. Okay, sorry about that. All right, so we've got negative 0.031. Can you have a negative time? No, you can't have a negative time. So that makes no seconds. No seconds. No seconds. I'm so sorry. I'm so distracted with the dog. All right, that makes no sense. Okay, so let's try the other one. So that's a goofy one. That doesn't make any sense. So let's try this one. Negative 125 minus square root of 15,881. I'm going to hit enter, and then I'm going to divide it by negative 32. All right, that makes sense. That's 7.84. So this is 7.84 seconds. This was something weird, like negative 0.03 seconds. Okay? So that makes some sense. So that's how long it took. Must have been a really big pop fly. It took a long time to go up and a long time to come back down. So that's what time it hits the ground. That's when its height is 0. And finally, the last little bit for this one. The y-intercept. Okay. The y-intercept is when the t equals 0. Remember, y-intercept means time is 0. Okay, so we'll have f of t equals, let me write out the problem again, plus 125t plus 4. So we're trying to figure out what the height is when the time is 0. So that's gone. That's gone. And then we have just 4 left. So when time is 0, the y value is 4, or the height is 4. So this is time is 0. So that means right before contact was made. And this is the height of the ball. So right before the ball is hit by the batter, it's 4 feet in the air. That makes sense, right? It's not like golf, you're not hitting off the ground. So this makes sense. So the ball is 4 feet in the air. Is 4 feet in the air before contact. All right. All right, the last problem, and then we're done. Again, it's kind of one of these challenging problems. It's like these ball problems. So here's the last one. It says a person throws a stone into the air. The height is given as h of t after t seconds. All right, so this is the same kind of concept, right? So here we'll have a person, okay? Gonna be a girl, and she throws this rock into the air, okay? So the path is kind of be like the baseball, right? Where it's gonna go up, and then it's gonna come back down, right? And hit the ground. And it's starting at a certain height, so imagine the C value is not going to be 0. Okay, so what is the height of the stone after 3 seconds? So we like it when they give us the time value because they're easier to do. So the height after 3 seconds, okay, we're going to pop 3 in for T. Okay. We're going to pop the 3 in for T and just pull our calculator out. Okay, plus 52 times 3 plus 4. So it looks like the height is 112 feet in the air. All right. What is the maximum height of the stone? Okay, this is good. I'm glad I typed this one up. The maximum height is at the vertex, right? Now this formula will be on your final and on your test. It's going to say x equals negative b all over 2a. So you don't have to memorize this, but you do need to know what it means. So let's look at what our a, b, and c are. So a is equal to negative 16. B is equal to 52, and C equals 4. So to find the vertex, instead of X, I'm going to put T, is negative B all over 2 times A. All right, so let's see what that looks like. I'll put it in a fraction. All over 2 times negative 16. Oh, I don't like the looks of that. All right, 1.625. So after after a little bit over a half a second, the rock's going to turn around and start falling back down. But they want to know what the maximum height is and how long did it take. So that's how long it took. So to figure out the height, we're just going to put that time into our formula, right? We're going to figure out what h of 1.625 is. So we'll have negative 16 times 1.625 squared. I'm just putting this into my formula. That's not bad, right? Okay, so negative 16 times 1.625 squared plus 52 times 1.625 plus 4. So it looks like the height of the stone before it turns around. I must have screwed up something upstairs. Let me do this one more time. You ready? So negative 16 times 1.625 squared plus 52 times 1.625 plus 4. All right, I'm standing by this one. I must have screwed up something upstairs. For 46.25 feet. You see how this answer is causing me some concern? So let's pop 3 in there and see what we get. For 3 seconds plus 52 times 3 plus 4. Somehow I beefed this up. So this should be 16 feet. Let's try this one again. Just like we were in class, I'm going unedited. I feel badly for the people who are screaming into the video that I screwed something up. But this is good. This is good that we did this, because if this was the maximum height and this is how long it took, then that being 112 made no sense. I don't know what I put into the calculator. You guys probably were watching me do it, and maybe I forgot the negative. But it's good. Like, this is kind of when you take a step back and you think about your answers. The fact that this was 46 as its maximum height, and we got 112 up there, something happened, right? Does that make sense? Like how you kind of have to chew on this. All right, so that's good. So when was the height of the stone at 30 feet? Well, if this is the maximum, it definitely had reached 30 feet. And you're going to have two answers for this, right? You're going to have two answers where it reaches 30 feet. On its way up and on its way down. Okay, so let's figure it out. You ready? So you're going to need the quadratic formula for both of these. So we want to know at what time is the height of the stone going to be at 30 feet. Okay, so you got to make sure one side equals 0. So let's subtract 30 from both sides. So there's where one side of the equation equals 0. And then when you're done with this part, I want you to identify what the A, B, and the C are. And then you just got to pop it into your quadratic formula. So A equals negative 16, B equals 52, and C equals negative 36. All right, here we go. So my time is going to equal negative b plus or minus the square root of b squared minus 4 times a times c all over, crap, I screwed up again, didn't I? Before we go any further, oh God, the talk's making me distract me. 4 minus 36 is 26, negative 26. Did you guys notice that? Whew, I'm glad I didn't go any further. Man, for my last video, I'm really screwing up. There we go, minus 26. Let's fix all these. Thank goodness we didn't go any further. Holy schmacks. Okay. There we go. Whew. All right, all over. Here, I'll give you a pause so you can catch up on that one. 4 minus 36 is negative 26. So C is negative 26, and I popped negative 26 into that equation. I'm going to give you a second to catch up on this, because this is really just like class. All right, and this is all over 2a. Whew. So let's figure out what's underneath that root symbol. You ready? So we've got 52 squared minus 4 times a times c. So 1040. So this is negative 52 plus or minus the square root of 1040 all over negative 32. All right, let's figure out what we got here. So we've got negative 52 plus square root of 1040 all divided by negative 32. Okay, what'd you guys get? Did you get 0.62? So 0.62 seconds. That makes sense. And then negative 52 minus the square root of 1040 all divided by negative 32. I'll give you a minute to write that down. So then on its way down, 2.6 seconds. 2.63 seconds. So it happened on its way up at 0.62 seconds. So about half a second, and then on its way down at 2.63. So 2 seconds later, it starts coming down. It's just about hitting the ground at 30 feet. All right, the last problem. Let's see if I can do it without screwing anything up. All right, so when does the stone hit the ground? So the height would be 0. and we're trying to figure out the time values. Now it didn't start at the ground, right? It started at the person's hand, which was 4 feet in the air. So there's only going to be one answer that makes sense to this. I'm not even going to have you pause. Let's do it together. So A is negative 16, B is 52, and C is 4. Okay, so the time is negative B plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. So let's figure out what's underneath that root symbol. You ready? We've got 52 squared minus 4 times A times C. So 2960. All over negative 32. So one of them will make sense, one of them won't make so much sense. So let's see which one it is. So we've got negative 52 plus root 2960 all over negative 32. All right, you can't have a negative time, right? So it says negative 0.08 seconds. That makes no sense, right? You can't have a negative time. So let's do the negative one. So negative 52 minus square root 2960 all over negative 32. So 3.33 seconds. And that makes sense, right? Because at 2.63 seconds, it was on its way down, and it was 30 feet in the air, so it didn't need that much more time, about a half a second, a little over half a second to hit the ground. Okay, hit the ground. So you can see why these problems are a little bit of work, right? So these will be on your exam. They'll be on the final, so make sure you try the my math labs, right, which will be open. And then I have something for you. You ready? Here it is. Oh no, can you see it? These are our celebration fireworks. Woo! I'll just let you listen and absorb it. Take it all in. You're done. Woohoo! You did it, guys. I'm really proud of you. This last video was rough, man. I made a couple mistakes, but that's okay. We did it. We're done. Woohoo! All right, let me know if you guys have any questions over the weekend. The review will be posted today on Friday. Oh, actually, no. It'll be posted over the weekend. It'll be posted. I'll probably post it on Saturday. And then we'll review. You can review on Saturday, Sunday, Monday, Tuesday. Ask me lots of questions. The test will be Wednesday. We'll review for the final on Friday. And then you'll sign up for times for the final. So anyway, congratulations. You did it. All right, we will talk to you soon. Take care and have a great weekend.